In this video, we'll understand Theorem 6.3 and we'll try to prove it. And this Theorem 6.3 is also called angle criterion of similarity of two triangle, or AAA criterion of similarity of triangles, or AAA criterion of similarity of triangles. So what this theorem says: if in two triangles corresponding angles are equal, so we have two triangles, corresponding angles are equal. What are the corresponding angles? Angle B, angle E are corresponding angles, angle A, angle D are corresponding angles, angle C and angle F are corresponding angles. If these corresponding angles are equal, that means if this angle is 60 and this angle also 60, so then these angles are called equal. Similarly, angle A, angle D is also has to be equal. That means if this is 70, this has to be also 70. Similarly, same. This has 80, this has to be also 80. So then corresponding angles are called same. So now their corresponding sides are in same ratio. That means their corresponding sides, this side are corresponding sides, are in same ratio. Not saying are in same size, they are just saying in same ratio. So what does it mean? Let's say if this is 2 and if this is 4, that means what is the ratio? 1/2. Similarly, this and this also in the same ratio. Doesn't need to be a same size but same ratio. So this is 1/2 ratio. This also has to be 1/2. That means maybe 3, 6, maybe 4, 8, 1/2 ratio. It has to be in that ratio. That is what it is trying to say. And then hence the two triangles are also similar. So hence these two triangles are also similar. So now we need to prove that. So what is given? The given is angle B and angle E are same. We already saw angle B and angle E are same. Angle A, angle D, angle C, angle F are same. This is the given. And then what we need to prove? Angle B, AB upon DE sides AP upon DE. That means ratio of AB DE, AC upon DF, ratio of ACF DF, BCEF, ratio of BCEF has to be same. That means if AB by DE ratio is 1/2, then all the three also has to be 1/2. So if you don't understand what is ratio, let me explain this. So let's say AB is 2 centimeters, okay, then DE is 3. So what would be the ratio of AB upon DE? It will be 2/3. If you cut 2 and 6, it will become 1/3. Ratio is 1/3. So if AB upon DE is 1/3, then all other corresponding sides ratio should be 1/3. So it doesn't need to be 2, 6. It can be 1, 3. AC is 1. DF is 3, 1, 3. This is the ratio 1, 3. And BC doesn't need to be 2, 6 or 1, 3, but it can be different, like it can be 3, it can be 9, but their ratio should be 1/3. So this is what ratio and what we have to prove. If we have to say that ratios are same, their numbers has to be like this, can be like this, doesn't need to be equal. Okay, now we'll go back to the proof. So now to prove this, what we are doing a construction of a line between P and Q in the second triangle, which is a bigger one, which is kind of a, that has to be once you draw this line and the new triangle is forming, PDQ has to be congruent to ABC. So we need to draw a line such a way that the newly formed triangle will become congruent to triangle ABC. What is congruent? The angles of all the angles and the sizes of sides are same. Angles should be same and sides should be same. Corresponding angles should be same, and corresponding sides also should be same. That is called congruent. So we are, for construction, we are drawing this line. We are drawing this PQ line, and we are constructing a new triangle which is congruent to ABC. This we are doing to prove what we have to prove. This we have to prove. For that we are doing this construction. Okay. Now, so we constructed line PQ. So now what we can say, since we have drawn a new triangle, uh, we have formed a new triangle by drawing this line which is congruent to ABC. So then AB, side AB will become equal to side DP, and side AC will become equal to side DQ. We will write that. Now we can say AB equal to DP, AB equal to, sizes will be same, AB equal to DP, DP, this is from which, DP from DE, DP from DE, and we can also say AC equal to DQ, AC equal to DQ, and this is from, DQ is from DF, from DF. Now in the next step, now we will take this triangle and newly formed triangle, this triangle, and this triangle. We'll take this triangle and this triangle, newly formed triangle. Okay, so now we are taking this triangle. In this, what we are saying, what we can say, we already said AB equal to DP. Okay, AB equal to DP. We have already written on the top AB equal to DP, and we also, and the angle, these angles we already said, angle A and angle D are same from the given. So we are writing angle A. Oh, can't write it. We'll write it with pen. Angle A equal to angle D. Right. So now the third one we are written already. We are written already that AC equal to DQ. So what exactly is happening now? Now this is side, this is side, right? This is side, this is angle, and this is side. So with this we are now going to SAS rule. So with the SAS rule, if side, angle, side. So with the SAS congruency rule, congruency rule. So with SAS congruence rule, triangle ABC and triangle DPQ will become congruent. Triangle ABC with the SAS congruent rule, we are writing this. Congruent to what is that triangle DPQ. 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 So now then, if triangle ABC is congruent to triangle DPQ as per CPCT rule, the other two corresponding angles are also become equal. This angle, this angle, this angle, this angle will also become equal as per CPCT rule. So let's write that. By CPCT, angle angle B, angle P are same, and angle C, angle Q are also same. Then let's write that. CPCT. Okay. Angle B equal to angle P. Angle B equal to angle B equal to angle P, and angle C equal to angle Q. Angle C equal to angle Q. The next thing, after we write these by CPCT rule, now go back to what is given. The given one is angle B equal to angle E. Let's write that given. Angle B equal to angle, what is that? Angle E. Angle E. So if LHS are same, then we can write RHS are also same. That means we can write angle P equal to angle E. Similarly, angle C equal to angle Q, what is given? Angle C equal to angle F. Let's write the given. Angle C equal to angle F is given. These are given. And this is given. Angle F. And F. So then similarly, angle Q will become equal to angle F because the LHS are equal. So now we have come to the conclusion that angle P equal to angle E and angle Q equal to angle F. So now go back to the picture, and we are saying angle P, angle E are equal, angle Q, angle F are equal. So because these two angles are equal, then we can say PQ and EF are parallel. So what we have to write here, PQ is parallel to EF. PQ EQ is parallel to F. So the small check here. So let's consider this lines are not, we are kind of doing a back check. So if these lines are not parallel, then these angles will not become equal. This angle, this angle, this angle, this angle will not become equal. Let's check a cross check to just for a better understanding. So I have this triangle and I am making one line which is not parallel, right? So now will this angle, will this angle become same? Will this angle, will this angle become same? No. So this angle will not become same. Only when these lines are same, then this angle will become same. So maybe for a better understanding, we'll write a parallel line and unparallel line. Let's say I will write a line like this. So this is not a parallel line. So now see the difference of angle here and here. This seems like some 10 degree or something, and this seems like some 60, right? So they are not parallel. So if the lines are parallel, if the angles are same, then lines will automatically become parallel. Like this angle are same, this angle are same, lines will become parallel. So that is how we came to conclusion that PQ and EF are parallel, though they are looking parallel in the diagram, but mathematically we have to prove that. So now PQ and EF are become parallel. So the l- line PQ is become parallel to EF, is parallel to EF, because or therefore corresponding angles are equal. So now by theorem 6.6, now by theorem 6.1, which is BPT theorem, basic proportionality theorem. So what the theorem says, in a triangle, if a line is drawn between two distinct lines, then the two sides are divided in same ratio. Then two sides are divided in same ratio. That is the BPT theorem. Maybe let's have a look at it once more. This is the 6.1 theorem. Okay, so if a line is drawn parallel to one side of a triangle, parallel to one side of the triangle, intersect the other two sides in distinct points, the other two sides are divided into a same ratio. Into same ratio. Okay, came we have reached into the same situation where BPT can be applied. See, we have a triangle and we have written a line at distinct points which is parallel to EF. Then this the other two lines will be divided into same divided in same proportion. That means other two lines are these two lines, ED and EF lines are divided into same proportion. That means this is one, this is one. So that means PE by DP is equal to DQ by EF. That means proportion will be same. So by BPT, what we can write, DP upon PE is equal to, that means the proportion of DP and PE is equal to proportion of DQ and QF. DQ QF proportion will be same. That's what by BPT we are writing. In the next step, we have to write these into reciprocal. That means PE PE by dP and QF by dQ. Okay. Now next step we have to add 1 P PE by dP plus 1 both sides, QF by dQ plus 1. Now what we can do next? So now we can say PE plus dP by dP upon dP plus QF plus dQ upon dQ. Okay. So now after arriving here, now go back and see what is PE plus dP. PE plus dP is what? DE, or PE plus dP is DE, and similarly dQ plus QF is DF. So now we are replacing dP plus PE to DE, because adding dQ, adding dP and PE is forming DE. That is why we are writing. Now we can write PE plus dP, PE plus dP with DE. Okay. Then dP will be the same way. QF plus dQ, QF plus dQ can be replaced with DF. DF by dP. Now the next step, see somewhere in the top, so we have written AB equal to dP. So let's mark this as 1 for our for easier, make it easier. Okay. So with these two, 1 and 2, what we can say, we can replace dP with AB and dQ with AC. dP dQ, sorry, this was dQ. Okay. So now DE by dP, dP is equal to AB. AB and dQ is equal to AC, dF by AC. Now one more time we are writing this reciprocal. This is actually by equation 1 and 2. 1 and 2. Okay. Now we are reciprocating AB by DE equal AB upon DE is equal to AC upon DF. Now see what has happened now. AB upon DE equal to AC upon DF. Let's go back to the line. AB upon DE, the ratio of AB and DE is equal to ratio of AC by DF. Okay, so that is what we have arrived to so far. So, but similarly, we can also prove BC by EF. So similarly, BC by EF. Sorry, here we can similarly prove AB by DA. AB upon DE equal to, so now what will become AB by DE is equal to AC by DF, or upon, we can say upon, and then BC by EF. This is what we needed to prove. We go back, what we had to prove. We have to prove this one, AB by DE, AC by AC per DF, and BC per EF are same in proportion of this side, this side, this side, this side, this side, this side are same. That is what we need to prove. Now that first one is proved. This is by equations 3 and 4. This is by equations 3 and 4. By equation 3 and equation 4. Equation 4. Okay. Now this is proved. Next one, what we need to prove is we need to prove that triangle ABC and triangle DEF are similar. Then what is the meaning of a similar? If the two, how can we say that two triangles are similar? If their angles are same, corresponding angles are same, and their corresponding sides are in same proportion, then the two triangles are called similar. So we have proven that sorry, it is given that angles are same, and we have proven that corresponding sides proportions are same. So with these two, the triangle ABC and triangle DEF will become similar. Triangle ABC, triangle DEF. So now the second point is also proved.